Oh. Quick but still important thing. This is an official IETF meeting, first core interim meeting for this series. We're going to have 3 interims until IETF 110. Then the note well applies. Please get familiar with that if you're not already. And before switching to the main item on the agenda today, which is the cacheable OSCORE document, I just wanted to check quick with Karsten about the status of the core conf documents.
Yeah, I'd like to know that too. I sent some nits to the authors that I found in my Shepherd review, and we got new versions of the documents. I haven't got around to actually checking them, but I assume they are addressing the nits, except for one, which is that the media type registration text in Yang Sieber still isn't ready for putting the question in the media types registry email list, and that means that we can't really fill in that part of the Shepherd report. And I'd really like to have that duck in a row before submitting the Shepherd report. So that's where we are at the moment.
So that's Yang Sieber, and yeah, I also just seen your mail. I think your library is probably just fine because I also saw your exchanges with Ivail about that too.
Yeah.
But I saw recently all the 4 documents resubmitted, so I
Yes.
suppose that Seed and Komi though are still requiring some work to do on the nits.
Well, SID should be done. Again, I have to check that. Komai is a little bit longer, so yeah, let's see where we are with that. So maybe we will need new versions of these 2 documents, Komai and Yang Sieber. Or certainly Yang Sieber, but maybe Komai as well.
Okay, so please double check about Seed also if that's actually the intended final version. I know Michael is especially eager about that document moving forward. Hi, Michael.
Yeah, right. So the problem really is that if you have an ongoing communication between 2 people who are really slow in replying to the email, that's not a recipe for things going very well. So that's where they are at the moment.
Actually, thanks for taking care of the nits, and yeah, when you say so, we can really finalize this. But
yeah, I really want to get this done this month.
Same here. Okay, thank you, Karsten. That said, we can switch to the main topic for today, cacheable OSCORE. And I guess you all see my screen, but Christian will present actually.
Yes. So what I'd like to do today is to give you an update of what we've been doing with cacheable OSCORE, and try to get this into a direction where we could possibly gauge the working group's interest in it and where we should develop this further. This has been in parts driven by research I've been doing with HW Hamburg on evaluating this. So as a result, there are now implementations, but let's get started from the beginning. Next slide, please. So the kind of big picture is, in general, we can't do caching of OSCORE requests. And as a mitigation, the proposal is to allow clients to opt in to a mode of OSCORE where they produce requests in a deterministic fashion and can then all arrive at the same request, this consensus request that can even be cached by proxies that are not part of the group and still deal out responses to the group members. In the version that we would like to publish as a -1 in the next probably few days, we've processed the input from the last meeting. We are now building requests in something more like pairwise mode, and much of the distracting content about what other forms of consensus requests could there or can there be is being removed, because that's just more of a historic overview on how to get there and not distracting from the actual topic. Next slide, please.
Christian.
Yeah.
While I remember, could you please go back to the previous slide? So this is a group OSCORE consensus request. Yes, I see. I actually managed to read something before this meeting, which I'm extremely proud of. So I'd like to take the opportunity to ask questions. So a consensus request, you have two different types of consensus requests. One is the deterministic request, and that is a pairwise request.
Yes.
So when you say group OSCORE consent, you mean not a group mode request here?
Yes, the request is actually not in group mode, but it's using group OSCORE concepts, and the response is in group mode. So it's building on group OSCORE, but the request, as you say, is not a group mode request.
Yeah, that was the confusion I had when I read it the first time. I thought consensus request was a group request, and then it turned out to be a pairwise. Okay, yeah. Just a clarification. Thank you.
So all those requests are sent from. So while these requests are sent from any client in terms of key material and identifiers, there is one particular group member that is decided by the group manager, and the whole key distribution protocol that is used for this purpose. And this member has no public-private key pair, but has an ID like all the others, and everyone who wants to interact with that peer will notice that either it is a deterministic peer or it has some data in the key material that the participant doesn't recognize, so it can kind of try communicating regularly with it. Along with the key ID, there's also a hash. There are also rules about the hash algorithm transported. We have not kind of hammered that out to the details of how the KDC would do that, but which hash algorithm to choose and the length of that hash is inherently something, a property of that deterministic client group member. Next slide, please. So what a client does is it decides for a request that it wants to send it in deterministic mode, which means that it sacrifices a few of the properties that OSCORE gives it in order to get this cacheability, and then it starts building the request as if it were sending a pairwise request. But before it gets to the encryption part, it hashes everything that will affect the encryption. So it hashes the plain text, and it hashes the AED and the sender key, and then uses that instead of the shared secret, which it could not derive because it doesn't have a private public key material, in the derivation process. Other than that, it pretty much works like a pairwise request. So this ensures that just a brief moment. This ensures that the key that we are using here is only ever used for this very cryptographic operation, and only with those very parameters, and never with anything else that could later contribute to nonce reuse. Göran?
Yes, this construction here in 3. So what you typically would have in the HKDF, you would have some salt and some shared secret and info and L.
Yeah.
Or some, yeah. And in this case, H is not a secret, right?
H is not a secret, no. But the sender key of C star is the secret. Is secret.
Yes, but you're actually sending H in plain text.
Yes.
So I wonder if we want to change that somehow. So
we have to send H in plain text because that is what the server is using to get to the same key again.
That's fine, but we may want to have a secret which we put into, which depends on H, which we put as a second parameter in.
I mean, we are doing an HKDF to derive a secret from that publicly known, from some secret information to and some publicly used public information. Isn't that right? What the HKDF is for?
That's right. So that it might be sufficient, but I'm just noting that this is deviating from the pattern that we are using.
Yes, so in the pairwise mode, here in the place of H, there would be the shared secret.
Yes.
While the rest of this is the same. My understanding of HKDF is that as long as either the salt or the secret is kind of, you get the better of either. But if that is not the case, we might need some switching around here.
Yeah, I don't think it's, I mean, making this secret is not a problem because you share a secret among the participants in the group. I'm just noting that this is a deviation, so we might want to consider what implication that has.
Just a comment, if you switch them, you deviate as well, because normally you have a sender key there in the derivation.
Yeah, no, it's not a matter of switching. Replacing H with something secret, which has H as an input.
Okay.
Yeah. I think this would be just another round of hashing, but we can definitely go through that in more detail.
Yep.
To show, kind of basically look up the properties that HKDF has or needs to have to ensure that it's good to use this with a public input at one of those places.
Fine.
So I have a pretty dumb question. The whole thing is about deterministic requests, right?
Yes.
So I cannot use this for sensor data because sensor data change. So the same request gives me a different response over time.
So you cannot use this to transmit sensor data by kind of making a deterministic post or a deterministic put. But you can phrase the request in a deterministic fashion if it's a get, and then the response will be depending on the state of the resource.
Karsten?
Yeah, but that means that there are different signed responses floating around.
Yes, there are different signed responses floating around, and this is not about having the same signed response all the time. I'll come late. So what probably matters here is that the response is not sent with the same key, but the response is sent in group mode using a proper sequence number and a signature, and not with that key that can only be used for this one request.
Okay, so we have some measure of freshness in there.
We have, yeah. I'll come back to the precise properties.
I'm just trying to understand
Sure.
how this gets by without the freshness here, and yeah, okay.
Yeah.
Yeah. Okay. Yeah. No.
Please.
Okay. So just I don't know if it helps or in any way, but in group score we define the mode where you send in group mode and you get the response in pairwise mode. So it's basically you send a multicast and you get back a unicast, and this is apparently the reverse. Then you send in pairwise and get back.
You send in pairwise and get back something that could even be multicast out if there are many clients listening to that. And not with physical multicast, but with proxy responses, which kind of do a similar fan out. We have just that the response gets sent to everyone, at least everyone who ever requested it.
Okay, please go ahead. Thank you.
I just see a question on Jabber over there. Okay. But I think that's something to address at the discussion at the end. But next slide, please. So as we already had it, the request hash gets put into the request in an unprotected in plain text. Then there's a bit of a quirk that we'll have to do. That is, in group core we have this request KID, and in order to get proper request response binding, we use the request hash, or possibly something derived from it. Currently it says request hash as the request KID, because that's what ensures that the responses will match here. And then the request is encrypted. It gets put into a fetch request, not a post request, like an observe request would be, in order to ensure that the caches understand it's cacheable. And off we go. The server, next slide please, that receives it can take the public hash, do the same key derivation, and decrypt it. Now, given that it just derived this security context, it doesn't have a replay window to check against, and the basic, or it has a fresh replay window, and the replay check will always pass. But it's in this kind of cases where it can't be quite sure whether this is not possibly a replay in some sense. So it will always have to send a known sequence number in order not to accidentally commit nonce reuse. There's two more checks that the server has to do. One is that it checks whether the hash is actually matching the plaintext, which it of course can only do after unprotection. Basically, if that check fails, the client has already messed up terribly and reused the nonce for reused the key nonce pair for something. But it's still good if the server can kind of raise the flag here. And the other check it has to do is this whole game only ever works for safe request. You could probably extend it for idempotent requests, but I don't think there's too much value in it. And if it's not if that's not okay, or if there are any other permission issues, like the deterministic client is not even allowed to access that resource, that gives you a 401 protected response. Next slide, please. Then, other than in kind of regular OSCORE messages, the server can actually set a meaningful auto maximum age, which allows the cache to make an informed decision about how long to keep it, and sends it back. And here we have that part in group mode. So it does it protects the message with its own group standard key. It uses an own partial an own sequence number that it attaches to it, and it performs a signature operation which gives a source authentication for the response, and then it goes out in a 205 response. Next slide, please. So that was the mechanics of it. As kind of things that we explore on the document as well, but are probably not crucial to the whole operation, is that you can send those requests to a group as well. So you can have this many-to-many group situation. Although a bit of care must be taken to send the responding server's key ID then. And if given that this this whole setup allows an adversary to see that different requests are all hitting the same resource, it might be a good idea here to introduce padding in the responses if the responses are not constant length. So we introduce this padding option as something that you might use in this context. Kind of in regular OSCORE, the attacker can't know which resource is being requested. Now it still can't know the very resource, but it can at least observe that all those requests are going for the same resource, and the responses that come back obviously differ in some way. So there's something going on, and that's a way of how to hide that. Next slide, please. And this is one we probably should spend a bit of time on, comparing the security properties to what we usually have in OSCORE. So usually in OSCORE, we have a strong freshness statement that says the response, this response was created after the client created the request. Now this property is lost, because if we did not make this property lost, then an older cached response could never be used. So this is crucial for caching. What we still do get is relative freshness, in the sense that we can do something like, if we do an observation using this, we can still order the responses, and we get something like some kind of trust on first use freshness, in the sense that if we ever receive a response with that particular sequence number, we can apply the same processes with observation and reject any later response with a lower sequence number for that particular request if we want to compare them. Then request confidentiality, that is reduced by a tiny bit, which is just enough to ensure that the cache can pick the right response to serve. It might be worth pointing out here that, of course, if the clients do have some variation in how they form the request, say one sends an accept header and the other doesn't, those requests still do not look the same and don't contain the same cache key, but kind of it's a start, and any application that uses this probably has rules for doing normalization on the requests, at least at a best effort base. And the kind of hardest property is that we lose source authentications for clients, because we want a response to be usable for every client that might request it, even if it doesn't go through the server. So if we even if we kind of managed through other means to preserve client source authentication for clients by, say, putting a signature somewhere in a non-cache key option, in practice that would still mean that the responses that are out there might not reach that very client, but a different one. So this is kind of by design that this is lost. Source authentication for the server is an important property that is obtained, that is preserved. So still no member of the group can impersonate the server. Questions here?
So is there any way to put back in request confidentiality, and at least against outsiders?
The thing is, we want requests to be aggregated by a proxy that is an outsider.
Yeah.
So the information that an outsider has to be able to obtain is that two requests are for the same resource.
Right.
If it can't obtain that and that is the only information that we leak compared to regular OSCORE.
Yeah, so maybe it's worth thinking about a situation where the proxy is an outsider to the group, but still is something that is more trusted than a random attacker.
Mm-hmm.
So I'm just thinking whether there's anything that can be done there.
So a comparable setup that I know that can do such things is Tahoe Labs, the least authority file system, where they differentiate between can verify the response but cannot read it, or can read the can interpret the path but cannot do much more. I assume that something like this could be set up, but it would be a lot more complex because it needs different levels of keys and different levels of group membership.
Yeah, of course, you can always run DTLS to your proxy.
Yes, or nested OSCORE, or it's probably worth exploring, but I would my expectation on that exploration. So whoever is taking notes, please kind of put an exclamation mark with my name there, so that I add this to my points there. But my expectation on the result is that it would be a lot more complex, and it's probably out of scope for an initial version here. And kind of whoever has a use case for it could look into it more deeply. But I'll take at least a few first steps and see how far one can get here.
Thank you.
Easily.
Christian?
Yes?
So are you finished? Are you at the end of your slides, or?
There's one more point that's an open question, and then I'm going to next steps and general discussion. So if you have the question that you mentioned on IRC, I think we should that should go after, and if no one else has questions about this very slide, I would briefly go through the rest of them.
Yeah, I don't have much to comment here. I think I just wanted to say that some of the properties that you want is sort of reducing security compared to OSCORE, but that might be okay in this situation. And it's I think the emphasis here is on the limited and on the simple setup. that you have, and that I think that's fair. So I don't have any objections to the setting, although I haven't actually, the details needs to be covered. I mentioned one of these aspects on the key derivation, and I think there are other details that we need to look at in terms of how to derive the keys. And there is, but we can go. These are details we don't need to discuss here.
Right.
For example, the request key ID is now the hash, and so on. It's nice because it's taking an existing concept and it's using that, but pairwise keys is not pairwise anymore. so
yes, it's using the mechanics. It's not hoping to get its very properties.
Right. So and that we need to check.
Yes.
But it looks good otherwise, I think.
So next slide, please. Kind of one point that we know that is that might raise questions is that we have now two ways that the server can say this request is bogus, and they don't all come through the path that the crypto primitives usually guarantee constant time for. So if the hash check fails, the client, an attacker might get information about whether it guessed the AEAD tag right. Now I think this is okay because basically in a regular case that's already a client's fault, and in any other case the attacker will have a much harder time guessing a good AEAD plus hash pair anyway than with a regular AEAD. But still, it's kind of one of the things that we will need to go through while going through all the other documentation of why is this actually all okay. Next slide, please. So currently there are a lot of pending changes in the editor's copy. My plan is to submit a -01 in kind of the next days to week or so. That includes all those changes, especially those that came from actually implementing it. So EIO Co-op now implements what it says in the editor's copy. We've been running much of this in the experiments for the comparison of Co-op and ICN setups. And Marco has already announced that he would like to do something on Californium. So that's it from my side. Next slide, please.
Just curious on this.
Yeah.
What's one reason why you made this is because there was some bad performance comparison in the previous setup. How is it now? What does it look like? Do you have any performance measurements?
Yes. So the measurements. So I mean, of course, this is all for setups that are tailored towards showing that this aggregation can or cannot work. But in the setup that we did on the IoT lab, the preliminary results indicate that we get all those nice properties of that you otherwise find in information-centric networks, where the where the data can really be distributed throughout the network without hitting the server too much. The overall energy consumption should not be impacted too much, even by the asymmetric operations that we suddenly start to introduce, because at least if proper hardware is used, the energy consumption of a signature operation is in the order of magnitude of a request of a radio transmission, and sending the same package to everyone instead of sending it to the next hop or the next two hops once and then letting them distribute the information pretty much makes up for that. So the general results are good, but of course are only from a kind of
sure, I understand.
Implementation.
Another question: was this the use case where you announced potentially distribution of firmware updates? Was this? Yes.
So this is definitely something that can be used with firmware updates, because if clients use a pull model for firmware, where they've obtained a manifest and then basically get the firmware from a large central server, then they send their blockwise requests to the server, and as they know that kind of they are already giving away that they are fetching firmware because they are obtaining a megabyte of data, and what else could it be? They can opt into this blockwise, opt into deterministic OSCORE, send the requests, and many other nodes on the network will already have fetched that firmware, and they can use the responses they got, send them to the requester, and then the requester can get a representation of the firmware without ever hitting the server, while preserving.
So that's really a killer use case, I think. I think that you're telling me though that it's not just a proxy that can, or cache that can respond, but that any member of the group.
Not even any member of the group, any node. I mean, so this all.
Or any. That's right. It doesn't even have to be a member of the group. Any node that heard the request could respond if they had it in their cache.
So, maybe let me briefly kind of explain a bit of what we've been doing in the NDN comparison, because this is motivating a lot of this. The way we often think of CoAP is to use it end-to-end from IP to IP address, but we have all those facilities for proxies in between. So no matter where we sprinkle in a proxy, it can be useful. And in the easiest place to put a proxy would be in the border router of between 6LoWPAN network and the rest of the internet. And then that border router could have a cache of that firmware, and that already kind of really takes a bit of stress off the uplink. But really, I mean, compare a DSL line with a 6LoWPAN network, and the 6LoWPAN network won't take down the big server.
Actually, it's in a number of cases, it's for firmware update. It's actually rather important that observers on the uplink or on the server can't tell which nodes have upgraded at what point.
Good point. Didn't think of it like that, but that's a bonus.
But aside from the stampeding herd of elephants problem, okay, the privacy issue is there, and then the other question is, you know, does this extend? And I don't think it does. Does this extend to the point where a node never needs to communicate with the source of the firmware?
Yes. So the one thing is, if you never communicate with the source of the firmware, you never get a freshness statement.
Of course. Okay.
So unless you have some synchronization in place, be it because you have a GPS time, be it for some other reason, that would give you anything that you can put the results in relation to, then you could always be a year behind and watching recorded television. As soon as you have something to hold on, you can. So if you don't have anything to hold on, I would be careful to use this for firmware updates, because then you could be kind of, someone could be slowly skewing your time to the 80s.
There's a movie for that.
But other than that, yes.
So please put that into the use case area. I'm sorry, I guess we're getting into that conversation now. I don't want to jump to it.
Yeah, it's a good point. I'll take it up there. I just kind of briefly like to finish the train of thought on the border router. What we've tested in that on the IoT lab is that you can take it further. You can even use the individual nodes along in a 6LoWPAN mesh as limited caches, and if they have those responses, they can serve them. That leads to interesting effects on the shape of the traffic, in the sense of how much data is there in the CoAP header versus how much is there in the 6LoWPAN header. But it can be done, and it gives good results, at least in the scenarios that we've been creating.
Have you tested with blockwise?
No, not yet. Okay. So one thing that will so one thing that will make this how do I put that best? One thing that will need a bit of exploration is how this is best traded off between inner and outer blockwise. Because the experiments have shown pretty clearly that fragmentation is pretty bad, and once you're over that threshold of the link layer MTU, you're in big trouble. And I'm kind of feeling reaffirmed for having worn that message overhead kills a t-shirt for a few IETF events. So if this is used for firmware updates over radio, you would probably have to find a good trade-off in terms of inner versus outer blockwise in order to make up for the 64 bytes of signature that are on every outer block, on every inner block.
Right. Yes.
In general, it was rather tricky to get both the request tag that needs to have a certain length and the signatures into packages that will in the end not fragment for the tests. I mean, it's kind of the signature is half the MTU, so
yeah,
go figure.
Right. So okay. So maybe fragmentation on other level would be more.
Yes. So if we transport if this is used for anything larger than kind of very small data, then it's probably advisable to use outer fragmentation to get down to the link layer MTU, and to then use inner blockwise for a same size of blocks, say possibly 4K or so. I mean, if it's from where you have to put that data somewhere, anywhere, maybe 1K, maybe 4K, something that you can reasonably manage in a blockwise fashion.
That makes sense. Okay, thanks.
So just Michael, reading your comment on Jabber, I think the question of whether you're convinced that this is a problem that needs solving has been addressed.
Well, so it's not the only way to do some kind of caching of firmware updates, and so if that's the killer app for it and there aren't any other use cases, then I might say, well, maybe we actually should have a bespoke protocol for firmware updates. And there, so at least that needs to go into section 3.1. Carsten asked a question earlier about doing requests against the sensor, and I can imagine. So in this case, the sensor is quote behind the proxy, and there's some number or a large number of requesters in front of it who, you know, it's sufficient. The temperature doesn't change more than every couple minutes, and you have 1,000, you know, devices that want to know the temperature. So maybe that would make sense to me. Yes, when the temperature does change, that invalidates the cache, and you know, they all get a new thing. I think that somewhere that should be contrasted maybe to using observe.
This can be combined.
Okay, but so, without the proxy, do you get the same effects if you multicast and observe to all the listeners, right? It's a different model, I acknowledge. But
so the thing is, this has with observation, this is multicast responses. And in multicast responses, what we've been doing originally, and will probably still be doing because this document is just behind the other one, is to create the consensus request in a different way, and have the server serve that consensus request and kind of do some extra work to get where we get here for free. And then we have an ongoing observation over which we can send out the notifications.
Okay, so I also hear that we need to have some text or another document that kind of compares and contrasts these different things, such that someone doesn't have to be an expert at all the different things in order to figure out which ones to use. I think that some more real-world examples would be useful. A concern that I have about should we do this at all, is how is this configured such that it is enabled? And given that we've made some compromises in the OS core properties, which we're not sure are safe, or we may be safe for certain circumstances and unsafe for other circumstances, how can we be sure that a proxy and or respondent hasn't been tricked into doing this by when they shouldn't have been, right? So
the proxy is always good to do whatever it wants because it's not part of the group and it's an outsider for all purposes here anyway. As far as the server is concerned, there's two aspects to this. One is that, and that's one that a library can check mechanically, provided it's trusting its users to kind of use it right, is that this is only ever accepted for safe requests. So that's something that should not need much configuration, because if a GET handler has side effects, then that server might already be in some other kind of trouble. On the point from the permissions point of view, I think it would be I think it should be generally safe for group situations as long as the deterministic client is given only the permissions that any member of the group automatically has. From a practical point of view, without any shoulds or probably, this is something that would be best to configure on a per resource basis and possibly be advertised. Advertising, of course, means that the client could again be tricked into doing this. So there might be a configuration on both parts that is necessary. And yes, this does need further examples and exploration.
On the permission part, I think the draft says already that the deterministic client has the minimum common set of permissions of all members anyway.
Yes. That's partially because everything that is going into the encryption part is only affecting the authenticated data of the response. So a group member that would not have the permissions could take a captured response and read data from out there. Similar to this is really similar to the general case of group security, where if you respond in group-wise mode, then your response is public to the whole group, which is the reason why you have pairwise.
I think it was the last slide anyway.
Yes. And it's already a lot of good input for the -01, which then probably won't happen this week.
Yeah, great work. Good to see it's progressing.
Thank you.
And also the implementations. That's the driving force here, and that's as Michael mentioned on that there is a reasonable, interesting application for this. And I think, I like this technology, of course, but I think that it definitely makes sense to have. We haven't looked so much for group OSCORE in itself for sort of the performance aspects there, but that's another reason why that type of estimates are important, I think.
Yeah, performance of group OSCORE hit me pretty hard when I first set up everything for the testbed, because that was the first time I realized how expensive asymmetric cryptography still is. I mean, I don't even want to guess how much an RSA signature would take on an embedded device. But even a software signature takes like a second or so. And this is all, I mean, this and group OSCORE in general, in my opinion, is only really feasible if you have hardware acceleration for the cryptography part. For the asymmetric cryptography part.
Yep.
Okay, any more comments, feedback? Okay, then we are done with this item for today. We have a lot of time spare, so is there anything more you wanted to raise and discuss today? Also other topics? Take that as a no. So I think we can even close the meeting pretty earlier than planned, and the next one in 2 weeks will be about dyne links with Bill and Alan that promised to run the show.
Woohoo!
Yeah.
So one observation that is not directly related to core, the CBOR working group may be looking for a new chair.
Yes.
So yeah, if you know someone or are someone who could do that, please talk to Christian and or the AD about that.
Thanks, Karsten. Okay. Any more plans for today? Okay, then we can close the meeting. Thank you all for attending and the feedback.
Thank you all.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Bye.
Thank you.